Alright, this is a video on average rate of change. So if I look at this first slide here, it says sketch the inverse graph of the function shown below. So let me write in red here what the points are. Let me get these points, the ones that I'll so this is 2, 1 here. And this point is 3, 2. This point is 1, 2. 0, 5. And 4, 5. So if that's the points of the original, the points for the inverse, make a table of values here for the inverse. So x, y. So the inverse of this point would be 1, 2. Inverse here, 2, 3. Inverse of that point, 2, 1. Inverse of 0, 5 would be 5, 0. And inverse of 4, 5 is 5, 4. So let me go ahead and plot these. 1, 2 is right here. And then 2, 3 is right here. I don't know why it's not plotting a dot. 2, 1, this one. 5, 0. And 5, 4. 1, 2, 3, 4 in here. All right, then I want to draw a parabola shape through there. All right, there's the inverse in blue there. And then how can we restrict the domain in the original? So the inverse is also a function. So right now, this is not a function because if I do the vertical line test, I hit more than 1 point. And this also, you can see in the table that there's repeated x values. So there's not a unique y value for every x value. For 2, there's both 3 and 1, and for 5, there's both 0 and 4. So if there's repeated x values in the table of values, it's not a function. So in order to make it a function, you're going to have to get like just a branch of this parabola here. So let me draw that in orange. So if I just get this right side here of this parabola, then the inverse is going to be a function. So there's multiple answers. In fact, there's infinitely many answers, but most of the time we go to the vertex there. So we'd say x is greater than or equal to 2 to get the orange part of the graph. And then the explanation would be when x is greater than or equal to 2, you draw the inverse in purple. The inverse would be of this graph right here. So 2, 1 becomes 1, 2. 3, 2 becomes 2, 3. So it would be this. Oop. Try to draw that better. So it would be this top part of the parabola here. if x is greater than or equal to 2, in the, let's get out of there, in the original, then you get the right branch. It's the orange graph. The inverse would be a purple graph. Which is the upper branch of the parabola side. And the inverse then would be a function. All right, number 3, I would go right here to the vertex is at negative 3, 0. So then negative 3 clues you in that x is greater than negative 3 and x is less than negative 3. And this answer is the same as that one. And let's look at this. If x is greater than or equal to negative 2, that would still be on this right side of the branch here. So that one would also work. So there's 4 answers that work there. X is greater than or equal to negative 4. I get this part of the parabola that there's a kind of a looping effect there. And the same thing with x is less than or equal to negative 2. You get this looping effect where there would be repeated x values if you did the inverse. And slope should be familiar with this formula. Change in y over change in x. Here's the formula. Here's it in words. We can sometimes say rise over run. So slope can also be described as the rate of change. So for ABC Motors here, you could look at the slope here. And then for big cars, which business is increasing its profit has faster race? It's the big cars because the line is steeper there. So big cars has a rate of change of, I mean, I can look here and see if this is 4,000, this would be 5,000 halfway between. So each of these are 500. So this is 1,000 right here. The rise and the run is 1 month. So this is $1,000 per month. And then for our ABC Motors, so we're going to say the profit for big cars is $1,000 per month. For ABC Motors, there's a rate of change go to big motors, once again, each of these vertical grid space is 500. So this is 500 per month. So their profit is $500 per month. When I originally did this, I was thinking this is a scale of 1, and it would be 1/2 as opposed to 1 here. But this scale is not 1. The scale on the Y is 500. This scale, every 2 tick marks here is 1 month. So this is a half a month or 6 months. Let me say that again. It will be half a month or 15 days or so. Each tick marker, each grid line on the X is half a month. So 2 of these make up 1 month. So this is 1 month run, and the rise is $500. So ABC Motor has a rate of change of $500 per month, and Big Cars has a profit of $1,000 per month. So Big Cars, that is increasing profits faster. All right, the temperature of liquids heated, so that rises steadily over a period of 10 minutes is shown. What's the rate of change of the temperature? What feature of the graph shows the rate of change of temperature is constant? So you can pick any points here. So let me pick this one here. This is 865. So I'm picking the point 865. 8,65. And another point I could pick is right here. So that's 655. So the rate of change or slope would be 65 minus 55 over 8 minus 6. And that's equal to 10 over 2. So the temperature is changing 5 degrees per minute. And the feature of the graph that shows the slope shows the rate of change, and the line has a constant rate of change. All right, the graph describes the motion of a computer-controlled train set. The rate of change of the distance is not constant. What's the rate of change of distance over the whole 10 seconds? Remember, the average rate of change is y2 minus y1 over x2 minus x1. So the 2 points that we're going to look at over the whole graph here is 0, 0, and 10, 100. So in order to find the rate of change there, is 100 minus 0 over 10 minus 0. Over 10 which is 10 centimeters per second. Oh. So find the slope between the beginning ending point. So in between here, this rate of change here between 6 and 8 is greater than between 0 and 6, and then greater still between 8 and 10. So if we were describing what's happening with the train here, it starts out at a certain speed, then gets faster. So for the first 6 seconds, it's changing at a constant rate. Then it goes faster at a constant rate between 6 and 8, and then between 8 and 10 it goes faster still. All these graphs are made of straight lines or line segment. What does it tell you about the rate of change for any line or line segment? The rate of change is constant. All right, then they want you to find the rate of change between A and B, so I could draw a segment between those two, A to B. All right, and then I could find the order pair for A. So A is at 0, 10, and B is at, so let me scroll down here and see the scale. So it's halfway between 2 and 4, so that's a 3. And each of these tick marks is 2, so 20, 22, 24, 26, 28. So 3, 28. And then the rate of change would be 28 minus 10 over 3 minus 0. A is equal to 18 over 3. Which is 6 volts per second. Next, I want you to find between B and C. So once again, we use a different color here. So between B and C, I could draw a segment. And B is at 328. We found that on the other slide. And C is at 5.5 and 38. So the rate of change there, 38 minus 28 over 5.5 minus 3 is 10 over 2.5. There should be a decimal point there. So 10 over 2.5. That would be 4 volts per second. And then from C to D, notice that as time goes on here, let me get the line segment. As time goes on, this curve is getting flatter, or the slope is getting less. So see, once again, 5.5 and 38. And D is 8.5 and 44. Total slope 44 minus 38. Our rate of change 8.5 minus 5.5. And that's 6 over 3. And that would be 2 volts per second. And then at which point in the graph you think the rate of change is the greatest? That's not the best question, but you can see at D, the slope is flatter than C than B. So A is really not the best answer, because at A you're at 0 seconds, but as soon as this problem starts, as soon as the time starts, the voltage is increasing the quickest at A. So they should have asked you by the previous slides between A and B, or between B and C, or between C and D. So it's increasing the fastest between A and B. So the slope of the curve at A is the steepest. And then the last slide here. The temperature of chemical reaction is monitored during what period of time is the temperature increasing? So you look right here, right about there at the vertex. So I'm going to call that 5.5. So X greater than or, and what period of time is the temperature decreasing? So between time 0 and 5.5. So we can put T here for time in minutes. And then this one would be 0 and T. And then 5.5. So I've seen this written both ways, with a greater than or less than, or greater than or equal to, and less than or equal to. It's probably, I don't know, in my mind, it's probably better just to do this. So, all right, so that's the rate of change Desmos activity. If you didn't finish it in class, then you can watch this video and get a better understanding of rate of change.